From production to distribution is a continuous and interdependent process. In this process, the demand for products determines distribution, and in turn, distribution determines production. As we have seen above, if we only consider each sector separately, there are countless options for efficiency in production and also countless options for efficiency in distribution. However, resources allocated to production are limited, so allocating resources in production must be synchronized with efficient conditions in distribution. It is the signals about individual satisfaction through efficient distribution points that will determine society's production plans to meet those needs. The Pareto efficiency integrates production and distribution, meaning there is no other allocation method where at least one person benefits without sacrificing the interests of others, both in production and distribution. This implies that the allocation of input resources for production is unique to achieve efficiency in production, and likewise, the distribution of the produced goods is also uniquely efficient. If there were still another allocation of resources that could generate greater benefits for society, then the economy's state would not be optimal. The process of reallocating resources to bring society's production and distribution closer to an optimal state is called Pareto optimality. This issue can be illustrated through the example provided. A society consisting of two individuals, A and B, consuming two goods, X and Y. Assume the marginal rate of substitution between X and Y of A is the same of B and equal 1. Meaning the economy has achieved distribution efficiency and individuals are willing to exchange X for Y at a rate of 1:1. However, suppose the marginal rate of transformation between the two goods X and Y in the production function is 2, meaning the resources to produce 1 unit of good X are equivalent to the resources used to produce 2 units of good Y. By visual perception, it can also be seen that society is wasting resources by producing too many X because the value of 1 X is equivalent to 1 Y, but the resources used are twice as much. If 1 X is reduced and the resources are used to produce Y instead, then 2 Y are produced. Meanwhile, for individuals, the value of 1 Y can replace the value of 1 X. As a result, society gains an additional Y. This additional unit can improve the utility for A, B, or both A and B. This resource reallocation process is Pareto improvement because it creates net benefits for society. The process of shifting resources from producing X to producing Y will cause the marginal rate of transformation, resources, between X and Y to decrease. Meanwhile, the conversion will increase the total quantity of Y and decrease the total quantity of X, leading to an increase in the marginal substitution rate between X and Y. The resource conversion process only stops when the marginal rate of transformation between X and Y equals the marginal substitution rate between them, for example 1.5. At that point, the economy achieves Pareto efficiency because there is no further resource reallocation option to create additional value for society. The conditions of integrated Pareto are shown in Figure 2.4. On Figure 2.4, point Z star inside the Edgeworth box 0, X star, 0 star, Y star represents the efficient allocation and distribution where the slopes of the indifference curves of individuals are equal to the slope of the production possibility frontier, 2 parallel tangents. This means that the marginal rate of transformation in production between X and Y equals the marginal rate of substitution in consumption between X and Y for all individuals in society. At this point, the economy produces X star units of X and Y star units of Y. Individual A receives 0, XA units of good X and 0 YA units of good Y, while the remainder belongs to individual B. For every point on the production possibility frontier, an Edgeworth box can be drawn, and at least one corresponding point z star can be found. However, to ensure that the tangents at z star and 0 star are parallel to each other, there is only one unique solution. That is the Pareto integrated efficient point.